Yeah, let's continue. Before that, in the island, I have upload Appendix B for vector analysis, just to recap how to do vector analysis, the cross products, and all this. This one you go and have a look. Okay. So today we focus on curvilinear motion. So last lecture we already done the rectilinear motion, with this move in the straight line, and we have show you how to apply the sixth equation here, right? V equal to V ds over dt, A equal to dv dt, and a double differentiation of your displacement, A ds equal to V dv. And also we show you the 3 Newton equation, which is with the constant acceleration, V equal to Vo plus At, change of displacement equal to Vo t plus half a acceleration and time square. And then the third one is V equal to Vo square plus 2a and change of displacement, right? And then we have also show you the erratic motion, which is only can represent by the graph. This one sure will come out in your test one. All right, so go and have a practice on how to do this one. So we have ST graph, VT graph, and AT graph. Okay, as you move from down to S to A graph, you do integration. Differentiation. You do differentiation, and as you move down from A to S, you do integration. Okay. Today we look at curvilinear motion. So if you throw a thing on the earth, it will move in the curved line. So curvilinear motion, when you have an object move in the curved line, so a path or the motion of object also always defined in a 3D with its x, y, z, and we need vector analysis. So before the class, I asked you to go and download Appendix B. It is a recap of how to do vector. All right. So let's say you have a object move in a curvilinear motion. So curvilinear motion, we have a displacement, or we have a path function. Bracket t means is in the function of time. So it moves in the curve portion. And every curve is actually a part of a circle. Right? So circle always have a center of circle. So how we measure the center of circle is using the radius, the r. Right? So for curvilinear motion, we always start with the first position, second position, then mark the center of curve. Now, how you know the circle of curve is always go inside the curve. It's not outside the curve. So if you draw a curve, the curve is inside. It's somewhere inside the curve. And then you label as R. Right? So this is position vector. One is path function, one is a position vector, which is R. Curvilinear motion, we define our position as R and not S. If it's moved in a straight line, then we use position as S. But in curvilinear, we use R. Displacement, how we define displacement. Okay, displacement is delta R, which is the movement of R to R naught. Okay, so first position is R, second position is R, comma, which is from the center. Means the first position is from the center R, second position is R, comma, second position, and the difference of this R, we write. Important is the arrow. The arrow is from the last position to the original position to the last position, which is you see the arrowhead pointing from 1 to 2 position. and we label as delta R. Okay, so first for analyze collinear motion, you need to know the position. In this case, we use R, and the R is always from the center of the curve. We label as O, and then the arrow is pointing towards the object because it's a vector. Vector have position and always viewing from the center of the curve. Same with the second position, also from the center of the curve pointing to the object, and we label as R prime. And the delta R is the difference of changes of position, collinear position, which is from the first position to the second position. We label as delta R, and the arrow is pointing from the first position to second position. So this is a fundamental. And from the vector, we can write in this equation, which is R prime equal to R plus delta R. Another cheat code to remember for vector. Vector 1, vector 2, this is the origin. No matter how many times the vector go, 3, 3, and so on, and many more vector, and the last position is from here to here. This is vector, right? And the last one will be from the position, from the original to the last position. This is your resultant. Okay, so by meaning, say in this module you only have two vector and then the resultant. So how you draw? You always draw from the first position. We always label as V1, or in this case we label as R1. Okay, position center of curve, and then it moved to second position, which is this one, R2. R1 pointing like this, and then the resultant always from the origin to the last position. This is the resultant. Okay, in this case it's delta R. So the formula to remember is always the resultant always the sum of vector. Delta R, the changes of position equal to R1 plus R2. Okay. Yeah. Oh, because my triangular is a bit different from that one. My arrow is a bit different from what you see on the screen here. But what is important here is that these two vector, you can pull the R prime to continue with the second one arrow. You can combine the yellow color arrow, and then at the end you will get the red color arrow. If you don't understand this one, go to Appendix B and have a look. But the cheat code is what I write on the whiteboard here. You always find the first vector, second vector. You always put the second vector at the arrowhead of the first one. Means if you see arrow, this is called tail. This is called tail. This is called head. So you always put the second vector tail to the last vector head. Just combine the two arrows. And then you draw the resultant from the origin to the last arrow pointing. Okay. If you don't know how to combine arrow, then go back to Appendix B. Because all the arrow you have angle. Right? If you combine, let's say, if you combine two arrow, you just need to draw the angle and then combine the tail. Okay? Because each vector have its own angle. Right? Let's say this one is R1 and your R2 is going like this. So you always have an angle. So you just put the two arrows together and then combine with from the origin to the last pointing arrow. And if you draw, of course, in this module, you don't need to scale the arrow. We only interested in the direction, and then you just mark what is the angle. The magnitude, that what you learn in your secondary school, you draw, let's say this is 10 Newton, 10 kilonewton, you draw 10 cm. Then this is 5 kilonewton, you draw 5 cm. In this module, you don't need to do that. You only need to show me the arrow, the arrowhead, and also the angle, and then you combine them in triangular. And then you solve for resultant. Yeah. Okay. So vector have magnitude and direction. So this is what you need to remember. Okay. Okay. So in this case, the last position, if you see the arrow, is actually you take this one. The last position is from origin to the last position here, R prime or R comma. How to reach from origin to here is actually a combination of yellow color R plus triangular R. Make sense? That's why the equation is like this. So to find the displacement or the change of position, we rearrange the equation. We take the last position minus the early position with the same concept as S, rectilinear motion. Yeah. What do you? Oh, you confused with that? What around whiteboard there? Later we come back. Here you try to focus on here first. Okay. First equation for today. Okay. So here, how you get your displacement? You take S prime minus S. Here, curvilinear motion. Curvilinear motion, you change the S into R. Delta R equal to R prime minus R. Velocity also same. You know velocity is ds dt. In a curvilinear motion, you just change the R into S. Okay, so we already go through this one in the previous chapter. With this V average is delta R delta T or delta S delta T, but this is curvilinear motion, we use R. So to remove the triangular delta, we have a limitation of that, means we freeze the time to 0, and we can change the delta shape into D. Okay. So I put here because I want to put side by side what is the difference between curvilinear motion and rectilinear motion. Basically, they are the same thing. All right. Okay. Okay. So what I want to highlight is this sentence. This sentence. When you draw an curvilinear motion object, the R is always 90 degrees to the curve. Always, when you do analysis, you want to find the velocity of this object at this point from the origin. You want to find the velocity of this point, always 90 degrees. Once you know the R, you can draw 90 degrees from the center. Yeah. Okay, so you draw something like this, V. The arrow always 90 degrees. This I will check from your answer. Don't your arrow always 90 degree to this line. So if you have ruler, always put your ruler, 90 degree ruler, draw the green color arrow and label as V. Same with the second position. You have the yellow line, so put your arrow, put your ruler there, draw a 90 degree there. So you have V1 and V2. Okay, so I go fast a little bit. So this is a presentation in mathematics. So you have a t and t plus delta t. It means position 1, position 2. And you label as v and v prime or v comma is, you know that which one is the first, which one is the second one, right? Okay, so here, same. How you know the change of velocity? You take the velocity plus the change of velocity. Okay, and then we rearrange the equation, which is the delta v equal to v minus v, and you do the same derivation. Again, how do you take these two vector? You take this one, put on the white paper, and then put this one to the origin. Then you, or you can put on the tail or on the heads, right? It's the same. Then you draw a line or resultant line. It's the same. Yeah. So I do a little bit revision for the vector. Okay. So I copy the v. I copy the second v. I can have two way. One is what I show on the screen here. I copy the v and I put on the origin and I pull the v prime. So I can also draw an arrow from here to here. This is v resultant. Okay, how to find, how you know how to write the equation 1 equal to 2 plus 3. I mean, A equal to B plus C equation using this one. This always your result. This is the component. So you look at the triangular here. You know that these two is a combine. It's a continuous arrow. So from this one, if you look at the V prime arrow, this arrow pointing here, and there's an opposite arrow pointing it. So it cannot be this one. So what you take is this one plus this one. So this one is V plus VR. This one is your V prime. It's the same way. If you take V and you take V prime like this, and then you do the thing lah. So I think I don't want to go that way. As long as you know on the left hand side vector is a result, and then on the right hand side of your vector is the component that add up the result there. Okay, so this one you go ahead and read lah. So I go very fast here. Okay, just now the velocity move in the 90-degree, but acceleration is not. Acceleration is not, but there's a name for that curve. Call it hodograph, but this one is not inside your test, but just know that the acceleration move in the curve shape also, but it's not in the normal curve. The curve is called hodograph. It's just a name for that lah. And for curvilinear motion, remember, curvilinear motion, acceleration always acting inside the curve. For curvilinear motion, here is A towards there. So acceleration for curve always pointing inside the curve. Just remember that lah. Okay. recap of your vector. Your R in the 3D, you can represent as xi plus yj plus zk, you know, right? So they are presentation, different presentation on the textbook, but as long as in your answer, you can use I, J, and K, either with arrow or without arrow, with a dot or without dot, right? Okay. Recap how to find magnitude is a square root of your x square plus y square and z square. Okay. Direction, position divided by magnitude of r. This means you take this, the one in the orange color, divided by the magnitude. Okay. So this is the direction, and we always write something like u sub r. Yeah, this is revision for vector. Okay, just now is position, and then now we go for velocity. Velocity is what? You change the position, right? The rate of changing of position. Again, just to recap, position always 90 degree from the center, the R component, always 90 degree. So you take V equal to dr dt. So you can pull the dt outside, and then, or you can put dx dt, dy dt, dz dt. Yeah. So you write V equal to dr dt, and then you bracket the vector, and then you do differentiation, each of the differentiation. Okay. Okay, this is a bit mathematics. You can just ignore it at the moment. You can just ignore it. Because in your test, I won't ask you to prove. So I just ask you to apply. All right. Okay. I ask you to apply only. Okay, so basically what I want to see is this one. The two line here. You write dr dt. You write what is your r, and then you find velocity. You write v equal to dr dt, and then you write d over dt bracket, and then the vector, and then you expand the vector. Right? You expand the vector. So dx dt I plus dy dt j plus dz dt k. This one ignore it. This one. Okay. This one that I ask you to ignore, this one is important when you go to mathematics. Your calculus 1 or calculus 2, or your engineering maths 2 and 3, maybe lah. Okay. So this basically, you know that x and I is a vector differentiation. So what you do d dv, that one, u dv dt something like that. But that is not important. So at the end, you write v equal to vxi plus vyj plus vzk. Yeah. Okay, so far it's just mathematics, still mathematics. And then what is new is your position become r in collinear motion. Okay, and on your answer, you write v equal to your final answer. Okay. All right. Magnitude, same. Remember, put your answer in vector form, and also you need to tell me the magnitude and also the direction of your resultant. Okay, so this one is your x component square plus y component square and z component square. And the direction, always take your vector divided by magnitude. This is a bit different from the rectilinear. Collinear, you always need to find magnitude and direction. So just a reminder, velocity always tangent to the path. Acceleration, dv dt. So A equal to dv dt. This always have bonus marks. Always remember to write the definition of acceleration or velocity. So A equal to dv dt. So you have d dv bracket and then the v vector. At the end, you arrive at axi plus ayj plus azk. So far we are repeating the differentiation. And the acceleration, you can, acceleration, what is important here is always inside the curve. It's always pointing inside the curve. So it's like your palm, your palm, and then there's always your palm direction. Your palm facing what direction? It's the same. So you see the curve is always like this, and then the arrow is pointing down. Okay. But however, for this section, the first section here, if you put your palm, is pointing there. It's always pointing inside the curve. Like the first portion of the curve here is pointing up, but here pointing like this, pointing in. Okay. Okay, same, you have magnitude and direction. So magnitude is a square root of your x component, y component, z component. Direction is you take the acceleration vector divided by the magnitude. Okay. I want to highlight here as A, the acceleration is not always tangent, it's always pointing inside the curve. Okay, we go for a tutorial question. So let's say you want to use a weather balloon, and the weather balloon is horizontal position, which is the x position to the right, is given by x equal to 2t. And then the y position is given in the quadratic equation, y equal to x squared divided by 5. Determine the magnitude and direction for the velocity and acceleration when you release the balloon after 2 seconds. Right? So in this case, what you do it in the x direction first and then y direction first. Or you can write in the vector form directly, change the x in I form, change the y in j form. Okay. So again, always go for your origin. This is a curve. This is a curve. Quadratic is a curve. So velocity, you have two equations there. So you write velocity equation, v equal to vxi plus vyj plus vz. Okay, or you can write in dx dt plus dy dt plus dz dt. In this case, you look at the question, there's no z position. So z automatically you cancel, you write dz dt equals 0, you get 1 mark. In this case, there's no z component. And then you write, you cancel, you draw an arrow, you write 0, you get 1 mark. Means that you understand the question actually is a 2D question. Okay. So the first one, dx dt, the equation x equal to 2t. So dx dt equal what? Your x is 2t. You do differentiation t. What do you get? Equal to 2. Okay, you need to write. You need to write something like this. Vx equal to dx dt, and then is actually is a d over dt bracket 2t, and you get 2 meter per second. Remember the unit. Don't just stop at 2. You need to tell me what is the unit. Do the same for y. So y, what do you get if you do the same? Y equal to dy dt equal to what? 2x divided by 5, right? So this is a vector form. So x position is to the right. So after the value or the magnitude, they always have a direction. In this case, I just draw an arrow to the right. So dy also same. The answer is 8/5t. The x is 2x. So then you cannot because there's no t there. You cannot differentiate something that do not have t. So this is the careless mistakes most of the time. If you differentiate t, there's no t there. You get 0. So you need to substitute the 2t from the previous one. So you substitute there, you expand the equation, you get 8/5t. Okay, so this is the careless mistakes. Always use the information in the question. And then the direction is pointing up, right? The direction is pointing up. Then you combine the two. It asks you to find magnitude, direction of the velocity and the acceleration. So you pull the data out. So when the time is 2t, you substitute the 2 there. So after 2 seconds, what is your x direction velocity? It still remains 2 meters per second. But the Vy is 3.2 meters per second. At least 2 decimal place for this module. Yeah. Okay, magnitude. How you find magnitude velocity? You combine the two. So magnitude is you square this one, and square root. Vz don't have, right? So you press the calculator, you get 3.77 meter per second. Direction. You know that direction is tangent to the curve. With this, you can take inverse 10. Why I can directly use this one? I don't need to use magnitude vector without divided by magnitude, because this is directly x direction and y direction. So you can find the angle. So this is your x, this is your y, this is your vy, vx. This is the origin. This is the origin, so theta is here. So this is a right-angled triangular. Your v always 90 degree, vy go up. So this is a right-angled triangular. Tangent theta equal to vy, vx. So theta equal to inverse of your tangent, vy, vx. That's why you arrive at this equation. Okay. Always write the general equation. Don't substitute and then assume I know what equation you use. You can put 2 decimal place. Okay. Acceleration also same. Ax equal to dv dt. So you know that your vx is 2 just now. So your ax equal 0. So sometimes your test answer, it can be 0. It can be 0. It can be as simple as 0. Ay, you have 8/5t. You dt, you get 8/5. Unit is meter per second square. Magnitude, don't stop here. Always find the magnitude, which is the square of your x and y. You get 1.6. Direction. Where's the a direction? Okay, direction you can find in the tangent, which is 90 degree. Okay. Now, because from the diagram, you know the x is like this in this direction, y is like this. So acceleration is only one. Your x don't have you don't have acceleration in x, so you only have y. Y direction is what? 90 degree. Right. This one from you can read from the diagram. It's 90 degree. Okay. The next one is an aircraft takeoff. Described by a y equal to 0.01 x squared, which is a quadratic equation. So this plane is rising with a constant upward velocity. This is upward, means your your upward velocity is given. Your v is given. Determine the magnitude of the velocity and acceleration of plane when it reaches an altitude of y equal to 100 meter. So to solve this question, you need to draw. You need to draw where is your origin, and then you're given the y equation, which is 0.01, and then you need to find what do you get in 100 meter. You have Vy. So at 100 meter, what is your x? Take this number, substitute here, what do you get? You substitute your y here. You rearrange the equation, what x you get? X you have square root, that's why you have negative number and positive number. You take the positive. Okay, you have 316.23 meter here. So we don't have negative number, we only have positive here. So you know that y equal to vyt, right? The position of your y is actually take the velocity multiplied by time, you get your y position. So how long it takes to reach 100 meter? You know that your y value equal to v multiply t. You have a constant vy. So how much time you need to reach 100 meter? How much time you from this point to this point? How long it takes? You rise with the 10 meter per second. So 10 seconds, right? So you know your t, right? You substitute 100 here, and then write the equation, you get time equal to 10. Okay, so you have the answer already. So once you have 10, refer appendix C later. I think I upload the appendix also in the island. Go and see what the chain rules are. So you have y equal to equation, vy equal to dy dt. So you substitute the equation there. You have two unknown, one is t, one is x. So you can use change rules. You can modify this equation, dy dt, as a dy over dx multiplied by dx over dt. Basically, you cancel the dx, you still get back dy dt. This is the magic skill that you need to learn for dynamic. You always need to use chain rules to derive something from the question. Okay. So we move forward. So important is recall back what is chain rules, which is you take something dy dt, put in the form of x, because inside the equation you have x. That's why you are using the x here. The x and the x here. So dy dx, what do you get? If you take y equal to 0.001 x squared, dy dx is, you take this equation, dy dx, what do you get? 0.0012 x. Right, then x dt. Who don't understand the blue color, this one? Who don't understand? Yeah, this one is from this one, dy dt, dy dx. What equation you use this one? Okay, so here is dx dt. You know dx dt is the velocity to x direction, so it's vx. You know that your vy is 10. Vy is 10. And then from here, wait a yeah, correct. 0.002, you copy. What is your x at velocity 10 seconds here is this one. You want to find the position of your x, vx here. So your x is, from the origin, is 316.23. So you substitute the x in the x here. Then you have one unknown, which is a vx equal to 15.81. Okay. Don't worry, if the question need to use chain rules, I will mention in the question saying that you might need to use chain rules for the solution. That means you must use lah. But the question asks you in a way that gives you a suggestion. Okay. So in your answer, you draw an big dot and then you show me the vector vy 10 going up, vx go to the right 15.18. From here you can find the resultant, right? Resultant is over here, not 45 degree, you know already. Yeah, one is 0 degree, one is 90 degree. You have a right angle, you always get 45, right? If you have right angle, of course this is not 45 lah, but not 45, is nearly lah, nearly. So you square it, y square, because it's a trigonometry trapezium rules. If you're triangular, you want to find c square equal to a square plus b square. So how you get c is square root of a square plus b square. Right? That's why we use the square roots here. Direction is the tangent of your triangular. 31.31. Yeah, you use right angle triangular. And the angle is tangent. Then show me. It's very safe to label something unknown. Don't substitute value here because you don't know whether the calculation correct or not. And then label the angle V angle. Yeah. This diagram is important for your final answer. Acceleration, same. you need to recall back what you have in the previous steps. Y equal to 0.11 0.001 x squared, and you know that your Vy equal to 0.02x and with the dot Vx. Okay, where you get this one is from the previous one. Huh? Yeah. Yeah. Okay, so A equal to dv dt. You see as a y component first, then solve x component. You solve for y component, ay equal to dv dt in y component. And you need to use chain rules again because your y is in y and x and not t. There's no t inside, so you need to use chain rules. Or can use product rules. So this is, you assume it's a uv, so you the uv is u dv dt plus v du dt. So you let your u, this one, is this one. Sorry, this one. Because you're finding the acceleration, so you use the acceleration velocity equation. So this is your u, this is your v. Right? So substitute, run the chain rules calculation. Your dv dt is your v, is this one, your vy, and the chain rules is like this. Right, your u is this one. dv dt is your acceleration. And if you don't know the v, you just continue, write the vx. Right, v is this one. And then du, you continue to use your u here. Your du dt is yeah. So what is different from here to here? What actually happened? Du dt is this one. So du dt, actually your dx dt, what it become? Dx dt become velocity. Yeah, so here is a bit fast. So this one, how to from here to here is you du dt, take this one, du dt. So your dt, actually this is a constant value. Dx dt actually is vx. You continue the calculation. So you pull the constant out. You have x, ax, and vx squared. Yeah, you just combine these two equations. Pull the constant value 0.002 bracket, factor out. One you get aax, another side you get v squared because there's a bx multiply vx, you get v squared. So once you arrive at one equation, you already have the unknown. You know what you have when the x is so and so, y is so and so. So the acceleration will be 0. Okay. So your ay is 0. Ax you don't know. Vx you know. Mm. So your x is negative. X is negative. So you find the magnitude. You square the x component, y component, you get one answer. Direction, inverse 10, 0. So the acceleration is this direction. So even you curve your hand, look at the palm direction, this direction. It's not slowing down. It's just that the centrifugal acceleration is this direction. No. We are looking at the motion. We're looking at the motion, the centrifugal motion, the collinear motion. No, it's not pulling that way. This is the yellow arrow is actually is the vector in mathematics dimension. Uh, okay. Okay. This this does a highlight of vector. So basically, go and see Appendix B and Appendix C. Right. Projectile you did learn in your physics, so I go very fast. Okay. Projectile basically, we are modifying the 3 Newton equation here. In any projectile question, always you'll be given the VO, or sometimes you need to find that, but initially you'll be given one origin with a vector velocity, and you see it as a projectile question. The first step, you always break it into x direction, y direction. Okay, in the projectile question, always break the vector velocity into x direction, y direction. Always to the right. Vy always going up. Projectile question, always draw where is your direction, where is your axis, x over x to the right, y going up. And then the origin you need to see lah in the question, because different question, a different scenario, but always draw the object, the position as a red dot. You'll be given one velocity. Break the velocity into x and y. Do the same for the another position. Okay. Okay. You know that this is second projectile is from left to right, right? Do you know how to draw the velocity vector of this one? It's always tangent to the curve. Even it's not tell you where is the direction, it's always tangent to the curve. And then tangent to the curve, open your right hand or your this one, right? Or left hand also can, as long as it give you 90 degree. Okay, like this. Like this. Okay. Gravity always pointing down on the earth. Always 90 degree go down. Yeah. Mistakes, careless mistakes always here. Some of you draw your Vy go up. Don't confuse. The second position always go down. So your Y is go down. Not go up. This one, careless mistakes always here. Your Vx go there, Vy go there. Because when you open your hand, like this. Okay, once you understand this one, you can do the question already. Okay, just remember this is a collinear motion. So collinear motion, remember your position always in R. Okay. You see the Cartesian coordinate here. So the first location you have your x position, y position. Second dot here you have your x position, y position. So the question can ask you either the changes of x position or changes of y position. Okay, so this is just a space question. If you drop a hammer and feather in the space, the feather and hammer, feather and hammer, so both have different weight, but on the zero gravity, what happened? Will they arrive at the same time or hammer will drop first? Sorry, a vacuum. Masa yang sama, eh? Okay. So if you see this
Well, in my left hand, I have a feather.
video, is
In my right
actually
hand, a hammer.
drop
I
at
guess one
the
of the
same
reasons
time.
we got here today was because of a gentleman named Galileo a long time ago
This
who
is
made a
hammer,
rather
a
significant
feather a bit
discovery
blur
about
there.
falling objects in gravity fields. And we thought
Actually
that
quite big the feather.
where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time.
Okay,
How
so
about
both
that?
reach at the same time.
Bye.
Okay, recall these three motion equation. V equal to V plus AT, change of displacement equal to VT plus half AC square. V square equal to U square plus A delta S. For projectile question, recall these three, write any place, any corner in your answer sheet there. This one got marks on. And then see it as Y, you solve it in X direction and Y direction. Do it in one you on the answer sheet, you draw half, you draw a line on your answer sheet. On the left, you do X direction, on the Y, you do Y direction. Okay, then you write horizontal motion with its X direction and vertical motion is Y direction. So because the limited space, I do the vertical motion below there, but you can do on the left and right. Okay, so on the projectile, on the vacuum or on this Earth, our acceleration, these three motion equation you can use because you have a constant acceleration. So if you look at the projectile question, you throw something, the acceleration x always 0. Means the gravity effect in the x direction always 0. So you pull the first equation, v equal to VO plus ACT, change all these terms into x direction. Your AC is 0. Straight away, this is a standard step. You write this equation, and then you write AX 0, you cancel. Change the equation into, you write Vx equal to Vox. Vx equal to Vox means it's the x component is the same of initial x component. Where you get Vox? From your vector. You change this vector into trigonometry question. You break into cosine that equation. So tangent. So this is your resultant, let's say. So Rx and Ry. So Rx equal to R cos theta. Ry equal to R sin theta. Okay. So you have to recall this one. Because you are given the initial vector already. So Vx is cos your given vector. Is this one. Okay, second equation also same. You modify this equation by using Ax equals 0. So acceleration cancel. you arrive at your S here, because your projectile is to the right is X position. So you write X equal to XO plus VOXT. This is VOX. All this equation is in the X direction, horizontal motion. Oh, 3 o'clock already. Okay, I'll go very fast now. Okay. So the same for the third one. V square equal to VO plus AC S square, right? It's the same. So you only have VOX equal to VO, you remove the square. It's actually the same as the first one, never mind. But this step got marks on. Here, from here, you get around 2 to 3 marks just to derive the equation. Okay, this one is for the X component. You do the same for Y component. But Y component, remember, your G is negative. I'll show you the vertical, then we stop. Remember, your AY is negative G. Write the first equation. Modify the acceleration as this one. AC equal to AY, which is negative G. Your equation become this one. V become Vy. VO become VOY. AC positive become negative T. Do the same for the second equation. S become Y. SO become YO. T same. AC become negative G. Repeat the same for the third equation. So you have negative, AC become negative, and S become Y. You have 6 equations. From these 3 equations, Newton equation, you arrive at 6 equations. You can solve 6 unknown. One, you have X, you have Y, then you combine the product, and you get the answer. Okay. I think we stop here. Okay. Yeah, I think we stop here.